Recording in progress.
All right, guys. Good afternoon. Pick out that from me, please. Pick out that from me. All right. So today we're really setting the foundation for what is really the next topic that we're doing. All right. The next topic we're really doing is equations of coordinate geometry with a particular focus on circles. For the last week, some advanced stuff. We learn with the polynomials, with the surd logs and indices already. That's all this so far. Polynomials, surd logs and indices. We have some videos that I can send you. Alright? So as I was saying, we really want to get to the next topic, which is our add maths and pure maths topic. A topic that is on add maths and also on pure maths. And you'll notice so far, all the topics we do in the Tuesday, Friday, we find those topics on add maths papers, we find them on pure maths papers. Yes, you must realize that by now, consistently. To the point where when we're practicing questions, we literally can just go on with the pure maths questions. Because they are the same as the add maths. It might be a little bit more in terms of level of difficulty, but if you can handle the pure maths one, talk to the add maths students now, then you can do the pure maths one. And then we do the pure maths right away. Right? There's a question I want to ask though. I'm thinking, persons doing pure maths, can we have a session Saturday afternoon? Is it possible to have a session Saturday afternoon? You can have a session Saturday afternoon.
Yes, sir.
You have training in the morning. That's the afternoon. I'm saying afternoon, mean like 3, 4 o'clock. You know? Yeah, man. 3, 4 o'clock. Because right now, the Sunday, we're gonna be having class on Sunday. But no. Just to kick off the pure maths part. Right? The Sunday kind of tight at the moment, but I don't want too many weeks to pass before we actually start. But that means that there's some stuff that I'm dealing with that was supposed to close off. That's taking a little bit longer than I thought. So I'm just thinking that, I mean, we're still gonna have time, you know, because we can always put in any number of classes that we need to put in to finish off the syllabus. And we finish the syllabus early anyway. But I'm just thinking that, you know, if you can be available on a Saturday afternoon, right, the pure maths students in particular, then we can literally kick off the pure maths topics on the Saturday until we are able to push in the Sundays. But those will be online. Saturday will be online. All right, so we'll confirm it by Friday. Right? We'll confirm by Friday if all the pure maths students can join a session on Saturday and we can kick off the pure maths, the straight pure maths topics. So as I said, now today we're really setting the foundation for the next topic, which is coordinate geometry, which is coordinate geometry of circles. In CSEC, you would have dealt with coordinate geometry of lines, straight lines. Right? Coordinate geometry of lines. And today, I am really checking today for us to revise coordinate geometry of lines, because even though you'll be doing coordinate geometry of circles, you'll be doing coordinate geometry of circles, and you'll have to relate lines to the circle. So for example, you'll get a circle, and you'd have to talk about this line, which is called the normal, and you have to talk about this line, which is called the tangent. And you have to talk about this line, which is a chord. All kind of lines are about the place. You understand? So we need to make sure that we know and understand the coordinate geometry of lines. I don't. No, circle theory. Coordinate geometry. So we don't want. So I don't want to jump to the circles without dealing with the lines first. I'm gonna take today and just deal with the lines, and then I decide if Friday we do a classwork on the lines, depending on feedback, or we jump into the circles, depending on the feedback I get from the class. Because you're really not going to be doing coordinate geometry of lines in add maths or pure maths. You're going to be doing of circles. But you're going to have to deal with lines related to the circles. So you still have to understand lines. You still have to understand both parallel lines, perpendicular lines, intersection of lines, all those things, length of lines, everything, midpoint, you still have to remember all of those things. So this class really is about going through those basic things that you would have learned at CSEC, and then let me just answer this. Hello? Yes? I can come back later, please. I'm in a class now. I can come back later, please. For 8 o'clock. All right, guys. Sorry about that. Right. So it's going to run through back some of the CSEC stuff, maybe 1 or 2 examples, and then we're going to do some real examples that really test your knowledge and the understanding of these quadrant geometry of lines. So the first thing you see on the screen here is length of a line. I'm going to go straight to the formula. I'm not even going to the proof. Formula is right in the box there. Square root of the difference in x value squared plus the difference in the y value squared comes from Pythagoras' theorem. On this diagram here, if we want to find the length of this line, if we know this length, which is the difference in the two x values, and this length, which is the difference in the two y values, then Pythagoras' theorem will be used to calculate this length, which is what this is. So, sorry. So under here, well, the difference in the x values squared, which is really this length, and here the difference in the y value squared, which is really this length. And I was square rooted to get the length of this line. And that's when we know 2 points on the line. We can do a quick example with numbers, right? So I can do the second one, and I think I'm gonna do the first one. I'm gonna do the second one on the screen. This one. The length of the line PQ. Quick and fast, nice and easy. Just for illustration. Everybody here should know this already. This is CSEC stuff. Alright? So the length of the line PQ is equal to the square root of the difference in the two x values squared. These are the two x values. You want the difference between them. So I can write 2 minus a negative 3 squared. So I'm doing this x value minus that x value. So it's 2 minus a negative 3 squared. And then I'm going to do the difference of the two y values. So it's plus this y value minus this y value. That's negative 6 minus 4 squared. So you see, I carry the sign with the coordinate right through. Don't leave the sign, I carry the sign. All right? Then this becomes equal to, this becomes a 5, because that's really a plus. Minus minus is a plus. This becomes the square root of 5 squared plus, and then this becomes negative 10 squared. So this then becomes the square root of 125, and it is measured in units. Length of line in quadrant geometry is measured in units. Simple as that. Now this will be 100, and this will be 25. So the total is 125. Nice and easy, quick and soft. That is CSEC stuff. Just a matter of applying this formula, guys. No matter how many examples I do, if you apply the formula right, you're not going to get it correct. Square root of the difference in x squared plus the difference in y squared gives you the length of a line segment in quadrant geometry. Moving right along. Midpoint of a line. I always say to the students, a midpoint is like an average point. Like an average point, a point halfway in a line segment. So like the point is like an average point. And so it comes down that the coordinates of the midpoint becomes the average of the x values and the average of the y values between the points. Hello. Average of the x values, average of the y values. Simple as that. All right. So move along. We're trying to use this example. Down here, I'm going to use these 2 points again. And I want the midpoint. Let's say the midpoint is M. Then it is the average of the x values and average of the y values. What are the x values? X values are -3 and 2. Put that over 2. Y values are 4 and -6. 4 and -6 over 2. Average them. Once you do that, you will get the midpoint, coordinates of the midpoint. Midpoint is the average point. So these two give me -1, so become -1 over 2. These give me -2, so -2 over 2 is -1. So that's the coordinates of the midpoint of the line segment PQ. Midpoint is the average point, average of the X, average of the Y. When doing equations of circles, we're going to have to find midpoints at times. For example, we have a chord, might have to find the midpoint of that chord because we might want the perpendicular bisector which passes through the center of the circle. Get me? So we're going to need to calculate midpoint right here in order to calculate this perpendicular, find that perpendicular bisector. So as I said, because we're preparing for circles, we have to know and understand geometry of the lines. You have to know lines inside out if we're going to get to circles. All right? The next thing is gradient. Gradient is rise over run, difference in y over difference in x. Simple as that. Gradient on a line segment is the rise over the run between the 2 points. Difference in the y values divided by the difference in the x values. This is all C-sec. This slide actually comes off a C-sec slide from a C-sec class. Same exact thing presented to C-sec students. All right? So we're going to write down to the formula. We're all big students here. That's what we get. Difference in y over difference in x, because the rise is the difference in y over the difference in x. The only thing I say here is that you have to remember that the direction you use for the difference in y, you must use the same direction for the difference in x. Because gradient is also an indication of direction. Gradient is also an indication of direction. So let me explain what I mean when I say that. Let's say I'm doing the second one again. This one. These same 2 points. So I have the point P, which is -3, 4. And I have the point Q, which is 2, -6. And I want to find the gradient of PQ. Now, common M used for gradient, I'm putting PQ here to mean gradient of PQ. I'm going to difference in the y values over the difference in the x values. If I'm doing difference in the y values, and I use this point minus this point in terms of taking the difference in the y values, then when I'm doing the difference in the x values, I must use this one minus that one. I must subtract them in the same direction. That is the only thing we have to remember when doing this. And a common mistake for persons to do is to put the difference in x on the numerator. No. The difference in y that goes on the numerator because it is rise over run. Alright? So that's all we have to remember, guys. So I'm doing this one. I can write, let's say I'm using this point, I'm subtracting this way. This point minus that point. So it becomes this y value minus this y value. That's -6 minus 4 over. So it has to be this x value minus this x value. That is 2 minus, but this x value is actually -3. It's become -10 over +5, which works out to -2. If I were doing it the other way and subtracting them in the other direction, the result is going to be the same from subtracting it this way. And I'm going the gradient of PQ, difference in y over difference in x. I'm using this y value minus this y value now. That is 4 minus -6 over. So I have to use this x value minus this x value now. So -3 minus a 2. Up here I get a 10. Under here I get a -5. 10 over -5 is still -2. Nice and easy. That's gradient. That's how we calculate gradient. All right? Let's continue. The sign of gradient. I think the next slide about the sign of gradient. This is our C6 stuff, guys. Our C6 stuff. Sign of gradient. Sign of the gradient, meaning whether it's positive or negative. That's what I mean. Now, you should always take the sense of a graph, line or curve, as if it is going from left to right. As if you're going from left to right. Whether it's slope up that way or slope down that way, going from left to right. Even if it is a curve like this, think as if you're going from left to right along the curve. If you do that, you will always know the sign of your gradient. If you think of going from left to right. So if a line slopes this way, it has a positive gradient because going from left to right, you are going upwards. Your y values are increasing as your x values increase. Right? So that would have a positive gradient. If the line slopes down like this, and you're going from left to right, then you are going downwards. So you're not left with negative gradient, you're going downwards. Right? So it's quite simple. You're going straight across, you're neither going up nor down, you're going straight across. There's zero gradient. So the gradient is 0. But if you're going vertically, like this, a vertical line, then there's no left or right on a vertical line. So the gradient is undefined. There's no left or right on a vertical line. You can't put arrow this way and say you're going left from left to right. You can't put arrow the other way and say you're going from left to right. If you put arrow the other way, you're still not going from left to right. So you cannot see what the gradient is. The line is vertical. You don't know what is left from left to right on a vertical line. So the gradient is undefined. But another way to look at it is to say the line is vertical, like this one. Then the run is 0. Remember, it is rise over run. Between any 2 points. So if I use this point up to this point, there exists a rise, but the run is 0. There's no horizontal movement to go from one point to the next. But if I divide it by 0, the gradient will work itself out to be undefined. So horizontal line you have, and you're going from this point over to this point. Again, I want to calculate rise over run. There is no rise, but the line did not change its altitude. There's no rise, but there exists a run. So 0 divided by a number would be equal to 0. That's why a horizontal line has a gradient of 0. And a vertical line has a gradient which is undefined. Now listen, pure math students in particular will get situations like these to deal with. They'll ask you to calculate, for example, the equation of a line. And when you work out the gradient, they get it undefined. If the gradient comes out to be undefined, you must know it's a vertical line. And vertical lines carry an equation x equals some number. And horizontal lines carry an equation y equals some number. So if your resulting line has a gradient of 0, the equation of that line is x equals some number. If the gradient is undefined, sorry, if the gradient of your line is undefined, then it is vertical, and so the equation of that line is x equals some number. And if you, for example, you have a vertical line and pass through a point, say pass through the point 3, 3, 2. The equation of this line is x equals 3, because it pass through a point where x value is 3. Simple as that. So a horizontal line, I said these things get people in exam. Telling you. Simple things like these get people in exam. They don't get them right. If you have a horizontal line, and pass through a point, same 3, 2, it is y equals a number. Y over at this point is 2, so the equation of this line is y equals 2. Simple as that. These simple things get people in exams. Everybody comfortable with lines with gradient like gradient of m equals 2, you know. So the gradient becomes 0 or undefined, people get into problems with them. Alright? So let us get comfortable with those things. But everything is on the screen, as I just said. A positive gradient line is one that is sloping upwards as you move from left to right. A negative gradient line is one that's sloping downwards as you go from left to right. A zero gradient line is one that is horizontal. So once the gradient comes out to be 0, it's a horizontal line. The equation is y equals some number. Vertical line gradient is undefined. So if you calculate gradient and it comes out undefined, then you know the equation is x equals a number. That becomes the equation. X equals a number. It is vertical if the gradient is undefined. All right, CXC set questions with these things, pure math in particular, and the results coming out this way, and people get befuddled, get confused. You know these things are very simple and straightforward. So everything important, simple as it is important. All right, let's continue. Equation of a line. We're just gonna go straight into it because this is our C set. Everybody knows y equals mx plus c. So we use y equals mx plus c when we know the gradient and we know the y-axis intercept. Use y equals mx plus c when we know the gradient m and the y-axis intercept. All right. So basically that is it. Remember, for this to be the gradient, you must have y by itself as the subject. Let's look again. For this to be the gradient, you must have y alone as the subject. Not 2y, not 3y, not negative y. Just y alone must be the subject, or the number in front of x to be the gradient. And then this now is your y-axis intercept. Point where the graph crosses the y-axis. Right? Or the y value at the point where it crosses the y-axis. Right? So let's just go through thick and fast. I'm spend a lot of time on this. I think we really want to do a couple questions with this thing. Huh? Some of the questions, simple as they can take some work. Easy, you know, but they can take some work. Can show you a question that's after one thing, and it takes a barrage of work for you to get that one thing. One geometry question. That's a one, give some information, ask you to find one thing. But it takes a number of calculations for you to get to that one thing. All right, I think I might make that be the first example we'll do today, actually. All right, so don't expect it because simple, straightforward, basic questions. I do what he said. We're big people maths now. All right, so the other form of equation of a line is this one. It's my favorite. I used to call it my BFF. Y minus YP equals m into x minus xp. Most times, this will be the situation that you have. The situation that you have will be one where this becomes very useful. This is the type when you know the gradient and you also know a point. So this brings me to a conclusion. Where finding the equation of a line is concerned. If you're going to find the equation of a line, you need to know two things about that line. You need to know the gradient, and you have to at least know a point, coordinates of a point. You need to know the gradient of the line, and you also need to know a point that the line passes through. So the question does not give you a gradient. You calculate the gradient. Or they might give you some information for you to find a point. But you need a point, and you also need a gradient. And then this becomes your best friend for finding the equation. So the xp and the yp here represent the coordinates of your known point, and this is the gradient. And then what happened now? The x and y here, they represent all points on the line. So it's called a general point, representing this point up here. Or a general point. It covers all points on the line. All right? I can do an example of how we use this formula. Pick and fast, just for revision purposes. Now let's say we're doing this one down here. Nice and easy. This example right here. We know the gradient and we know the point. Let's do the equation over here. Just for illustration purposes. I think this is clear enough. Let's do this thing. Let's not assume. So I want a line which has a gradient of 2 and passes through a point R, which is 3, 5. I'm going to use the BFF formula. The equation becomes y minus yr, because r is a point, equals the gradient of the line into x minus xr. R is a point. So the equation becomes y minus yr is 5. Y value at the point is 5. That we know. The gradient is 2. Straightforward. The gradient is 2. This is just showing application. Into x minus the x value at the point is 3 right there. 3. Let's Find this out. 2x minus 6 transposes negative 5 becomes positive 5. We get y equals 2x minus 1. So we still know the gradient, and we still know the y-axis intercept, which is the c. We end up with them anyway. All right? So pick and fast, nice and easy. That is it. So far so good. It's all easy revision stuff. Nobody must know all of these. You all see separate. Right? And some of you will add more. So this is all easy stuff. All right, let's continue. So this is a summary page. And the key thing for the summary page is right here. Find the equation of a line. Must know two things. Must know the gradient. And must have a known point. If the known point is the y-axis intercept, then you're good. Y equals mx plus c, and you're done. The known point is some other point as we just stated. Some other point P. Then this becomes the equation. All right? We just did an example. I'm not going to do it anymore. This is another example, but I'm not going to do it. I just did one on one. I'm not going to treat you guys like in a CSEC class. Don't make no sense. This is add maths and pair maths. Big children. Right, sir? All right. Let's continue. I want to get to the notes. I want to do some questions. I want to do as many questions as possible. All right? Let's get to the notes. Reading the equation of a line. This is about plucking off the gradient of a line, for example, from the equation. The key thing is that you have to put it in the form y equals mx plus c, meaning you need to make y alone the subject. All right, that's what this is saying. The equation of a line must be placed in the standard form y equals mx plus c before we try to identify the gradient or the y-axis intercept. All right, just make sure body line is still there because not seeing. Okay. All right, so I said Avia just joined today. Avia was revising some ADMAT stuff, and we do ADMAT already. But we're preparing ourselves to do equations of circles. Now to do equations of circles, which is also an ADMAT topic, you have to master everything about lines. So let's just kind of do a quick revision of those lines stuff in this class today. All right, it's Avia coming for the first time.
Yes, sir. It's Avia, by the way.
Avia. All right, no problem. All right, so let's just continue. So this should be a revision for everybody in the class. It's just quick revision. We're gonna put a little sugar question on the board afterwards and see, you know, if it is really basic stuff. All right, let's continue. So plug off the gradient and the y-axis intercept from the equation, right? You must put y alone as the subject. In this example here, we see 2y as a subject by that 2 that is standing beside the y. To make y alone the subject. That is it. You know the gradient is 2. All right? Now they will give you equations like this, and they talk about the gradient. You have to plug off the correct gradient after that by making y alone the subject. All right, we just want to focus, we just want to emphasize these basic things. This one, you might get an equation like that in a question. You need a gradient, you need to transpose it to make y the subject. Transpose the x first, and then divide 2 by a 3 or multiply 2 by a third. So the gradient becomes negative a third, and the y-axis intercept is 4 over 3. Basic, easy stuff. Everybody good? Everybody good? All right, this is all C-set. All C-set. Parallel and perpendicular lines. Easy, easy stuff again. When you start dealing with equations of circle, you are mainly going to be encountering perpendicular lines a lot because you're going to be working with what we call a normal and a tangent to the circle. And they will have what we call negative reciprocal gradients. The gradient of perpendicular lines, negative reciprocal. So parallel lines have the same gradient, nice and easy. So two lines are parallel, gradients equal, right? Simple as that. No calculation needed there. Good? Simple as that. This is just all a reminder. The line is perpendicular, however, the gradient of one is a negative reciprocal of the next. And this is something that a lot of persons also miss. That the product of a gradient equal -1. And then this gives us this and also gives us that relationship. We have a shortcut method of finding the gradient from one to the next if they are perpendicular, which is to flip the one that we have and change the sign. That's a quick way to do it. Flip the one that we have and change the sign. That's what we're doing here. Flip it and change the sign. All right, so if I use some numbers to illustrate that, quick and fast, we're talking about perpendicular lines now. The parallel lines don't need nowhere. The parallel lines have the same gradient, right? Talking about the perpendicular lines now, which we're gonna see a lot when we're doing circles, equation of circles. So if one line, M1, is equal, for example, to 2, then the perpendicular gradient is -1/2. Because this 2 is the same as 2/1. You flip it, it becomes 1/2, and then you change the sign to minus. That's another thing. If the lines are perpendicular, one of them have a positive gradient and the other one have a negative gradient. There's no way perpendicular lines can have the same sign of gradient. It's not possible. Right? Also remember that a vertical line and a horizontal line are perpendicular. So whereas this gradient is 0, this one is undefined. They are perpendicular still. But we're talking about lines now that are not horizontal and not perpendicular, not horizontal and not vertical. One gradient must be positive and one must be negative if they are perpendicular. Right? So another example, gradient of a line, for example, is 3/2. Then the perpendicular gradient, the gradient of any line perpendicular to that one, must be -2/3. Easy as that. The gradient of another line, one last example, is -4. Then the perpendicular gradient must be 1/4. Flip the one that you have and change the sign. Everybody go to that? Online, everybody go to that?
Yes, sir.
Yes, sir.
All right. Good, nice and easy. Good, nice and easy. All right. Let's move along. Get through these notes quickly and do some questions. All right. So these are some examples. We're gonna do some real questions. So let's skip over this. We're gonna do some examples. Let's skip over this. Perpendicular bisector of a line. This is something that you might have to do when you're doing equation of circles. As I just showed you a while ago, you might have a situation where you have a circle and you have a chord. So you know these 2 points, A and B. And you need to find the center O. The perpendicular bisector of a chord will always pass through the center. So this is a chord. The perpendicular bisector of a chord will always pass through that center. This is a perpendicular bisector. You have to be able to calculate perpendicular bisector. It's very easy. It is as it says. It is perpendicular and it's also a bisector. So if it is perpendicular, it has a negative reciprocal of the gradient of AB, for example, right? And because this is a bisector, it passes through the midpoint of AB right here. And then with that midpoint and that perpendicular gradient, we can put them together to find the equation of the perpendicular bisector. That is it. It's quite simple. Summarize on the screen here. The perpendicular bisector of a line, AB, is a line which is perpendicular to AB and passes through the midpoint M of AB. All right, so if you have that line AB on the screen, that is the midpoint M. That is your perpendicular bisector. The 2 things about that red line you need to know to find the equation. 2 things about it you need to know. You need a gradient and you need a point. The point is the midpoint M, which you calculate as the average point between the A and the B. Remember, M is an average point. And then to get the perpendicular gradient, you calculate the gradient of AB using difference in Y over difference in X, and then you do the negative reciprocal business. flip it and change the sign. That would be the perpendicular. That would be the perpendicular gradient of the red line. All right. So that is it. We're going to calculate the gradient, the midpoint for find the midpoint, and then the gradient of AB. With negative reciprocal of gradient of AB, that gives us perpendicular gradient. And then we can calculate the equation using the midpoint and the perpendicular gradient. All right. I'm not going to do this one either, because we're going to do some questions just now. I'm not going to do this example. I get it. I think we understand this, guys. It's just a matter of executing, but we're going to do some examples just now. You understand the process of finding the perpendicular bisector online? Online?
Yes, sir.
All right, Miss Green.
I'm good, sir.
All right, and nobody in the classroom good as well. All right, we don't want to waste any time on this, but I'll come to the questions shortly. All right, point of intersection of two lines. Simple, you solve the equation simultaneously, right? If you want to find where 2 points meet on a line, 2 points meet on a graph, or the point of intersection of two lines, you solve the equations simultaneously, right? Everybody knows how to do that. You solve them either by elimination or by substitution. And that again is basic. We're going to do some questions, we have to do that. And we spoke about this. Equation of vertical lines. X equals a number. X equals a number. Equation of vertical lines is X equals a number. These are some examples on the screen. So for example, X equals 2.5 is a vertical line there passing through 2.5. X equals -3 is a vertical line passing through -3. X equals 7 is a vertical line passing through 7. Then we come to horizontal lines. Horizontal lines have an equation form, y equals a number. Y equals a number, like the x-axis is y equals 0. So, y equals 2.5, for example, is a horizontal line passing through 2.5. Here it is. Y equals -3 is a horizontal line passing through -3. Y equals 5 is a horizontal line passing through 5. And I think we're done. We're done. Ready for the question. Let's put it all together. Let's put it all together. All right, let me bring up how we're gonna do it from now. Let's finish that. Let's put it all together now. Yeah. All right. Here are some questions. Let me see if it's this one I want to do. Nah, not this one. Let's go to the next one. Okay, there you go. Let's start with a simple question. This one right here. Let's start with this simple question. Easy one. This one right here on the screen. Easy question on the screen. And I want some feedback in terms of how would approach this question before we start. Let's look at it. This question in the box right here. All right, this question, I'll do a number of questions today. That question in this box. The question gives us those two lines, line 1 and line 2. Also gives us these points, A, B, and C. What did it say? It says in the diagram, A is the point -3, -1, 3 right here. B is the point 3, 1, that is right here. B is the point 3, 1. And it says line 1 passes through A. See here, line 1 passes through A, which you can see that. Everything they have said so far is on the diagram. Line 1 passes through A and is parallel to OB, but they did not show OB. What is that? So line 1 is parallel to OB. So if I were to use a color for that, this line 1, I'm marking in blue, happens to be parallel to OB, which was not shown. There's an arrow on this and an arrow on that, to mean that they are parallel. If they are parallel, what do they have in common? What is the same about them? Same gradient. So can we find a gradient of OB? Can we find a gradient of OB? Yes, we can find a gradient of OB. Yes, from the origin. Remember, you know, from this point to this point, the gradient is just how much you rise divided by how much you run. This is the rise, and this is your run. So just your rise over your run. What is the rise? 1. If according to right here, so it's 3, 1, then the rise is 1 and the run is 3. See that? So the gradient is a third. Good? So the gradient of OB is a third, and the gradient of line 1 also is a third. But good at that? Talking it through before we do it. All right, and then when we know the gradient of this line and we know this point, then we can find the equation of line 1, don't it? Good. That's what it tells us. We go on to say, line 2 passes through B. See here, line 2 passes through B and is perpendicular to AB. So this line 2 is perpendicular to AB. And you can see the symbol for perpendicular right here. You can see it. These two lines perpendicular. So it means that these two lines, they have negative reciprocal gradient, don't it? All right. So how can we find? We know a point that you pass through, the pass through B. How can we find the gradient of that blue line now? Line 2. How can we find the gradient of it? They tell us that the perpendicular to this one. How can we find the gradient of this line? Negative reciprocal of what? And how can we find the gradient of AB? Because they gave us the 2 coordinates. Because we have the coordinates of AB, we can find the gradient of AB. And then with the negative reciprocal, that gives us the gradient of line 2. All right? The question asks us one simple thing. It tells us that line 1 and line 2, they meet at C right here. 2 lines, line 1 and line 2, they meet at C. And all the question wants us to do is to calculate the coordinates of C. So somebody tell me how we're going to do this. This guy just talk it through a while. Somebody tell me how we're going to get the coordinates of C. Beautiful. We'll just find the equation for line 1, find the equation for line 2, and then we'll solve them simultaneously. Simple as that. Line 1 equation, line 2 equation, solve them simultaneously. Online, everybody understand that? Everybody good at that? That's what we need to do?
Yes, sir.
Yes, sir.
Beautiful. Remember, to find the equation of the line, we need a gradient and a point. That's what we're looking for, the gradient and a point. So let's start. Let's start with line 1. So line 1, the gradient of line 1 is equal to the gradient of OB, don't it? That's what they told us, don't it? And the gradient of OB is a third. But can I agree that OB's gradient is a third? But I agree with that. And then line 1 also passes to the point A, which is -1, 3, don't it? Good? So the equation of line 1 becomes y minus, ya equals the gradient of line 1 into x minus xa. Agreed? Which then is y minus ya is 3 right here. The gradient of line 1 is the same as the gradient of AB, which is a third, into x minus the x value at a is negative 1. So you want to put x minus a negative 1. This becomes a plus. Then put a red plus here, so don't forget that it becomes a plus. This minus minus becomes a plus. Let's expand this out now and simplify it. I don't want those fractions. I'm going to multiply this third across here by these 2. And I'm going to get 3y minus 9 equals, I multiply this one inside here. Remember that's a plus. I get x plus 1 inside there. Good. Transpose this negative 9 and add to that 1. I get 3y equals x plus 10. This is the equation of line 1. This thing right here. Now I need line 2. For line 2, again, we need a gradient and a point. Line 2. Now line 2, the gradient of line 2 is minus 1 over the gradient of AB, don't it? Because they told us that it is perpendicular to AB. Where we can calculate the gradient of AB right here and then use it. Gradient of AB is difference in y over difference in x. Let's say we're using this y value minus this y value first, so the difference in y. These 2 points we get in the gradient of x between them, these 2 points. AB. Difference in y over difference in x. This, alright. So one safe way to find gradient is always use, remember you're going from left to right, use a destination point minus the starting point, right? So get into that habit. Right? Destination point minus the starting point, going from left to right. I'm going to use this y value minus this y value, depends on y. That's 1 minus 3 over this destination x value minus this starting x value, which is 3 minus a negative 1. This becomes what? Negative 2 over 4, don't it? Which is negative half. Negative half. But can I get that? That's right. 1. Let's look at it. 1. Let's make sure.
Yes, it is, sir.
Over 3 minus a negative 1. 1 minus 3 is negative 2. 3 minus minus 1 is 4. We get minus a half. And so the perpendicular gradient becomes 2. I'll flip this and change the sign and get 2, don't it? So the gradient of line 2 becomes 2. What about that? And then now, this is the gradient of line 2, but line 2 also passes to the point B, don't it? So we're going to be using the point B for line 2, which is 3, 1. Using this gradient and this point to find the equation of line 2. So the equation becomes y minus yb equals the gradient of line 2 into x minus xb. Y minus yb is 1. The gradient of that line is 2 into x minus xb is 3. I'm going to multiply this out here. Y minus 1 equals 2x minus 6. Transpose this 1 and get negative 5. Y equals 2x minus 5. This is now the equation of line 2. So now we'll solve these 2 equations simultaneously, don't we? We can use a substitution method. We can basically just substitute for the y. All of this, that line 2 is saying y equal to, take it and put it right here. So we're going to substitute for y, equation 2 into equation 1. Good? Nice and easy. Nice and easy. Let's go. So we're going to substitute. Let's see what we're doing. We're going to substitute 2 into 1 for the y. So we're going to get 3 times 2x minus 5. Remember it was 3y up here. Equals x plus 10. Equals x plus 10. This becomes 6x minus 15 equals x plus 10. Transpose this over here and subtract. 5x equals, transpose this negative over here and add. Get 25. Divide 2 by 5, x equals 5. X equals 5, take x equals 5 and drop it right here for the x. You get a y value. So we can say and y equals 2 times 5 minus 5. That is 10 minus 5. The y is also 5. So C is the point where x equals 5 and y equals 5. So C is the point. 5. That is it. Nice, easy question. So one simple thing to ask for, we have to calculate a number of things. All right. Oh, stay. Very good.
Yes, sir.
Okay.
Yes, sir.
All right. So it means that I need to give you one now. I'm ready for one here. Huh? Let me keep that one. Since we just did. I need to give you one now. All right, let's give you an easy one. Let's give you an easy one to do. This one here on the screen. This one on the screen. This is easy stuff. You know? This one right here. I'm gonna put the box around. Do that one in the box for me. I'll give you 5 minutes. Or less. Do that one in the box. Says the diagram shows a rectangle. Notice a rectangle. Rectangle has that rectangle of opposite sides parallel, but the adjacent sides are perpendicular, don't it? Also, not only are these opposite sides parallel, but they are the same length. Those two lines are the same length. These two sides are the same length. So come, put that into consideration as a question. Come. The adjacent sides perpendicular. All right. So it says, A is a point 214. It's a short right here. Yeah. Better. Right. B is a point. B is a point negative 28 right here. C lies on the x-axis. If it lies on the x-axis, I don't know about that point. It's on the x-axis. What is 0? So you know, this is a point on the x-axis. You have to use the fact, use what you know. That at that point, the y value is 0. Good? Use that information. Y value is 0. It says calculate equation of BC. So BC here, so. And coordinates of C and D. Calculate the coordinates of C and D. Come on, 5 minutes. Do that for me, quick and fast. What time is it? What time? Now, 6:15, it is 6:20. Come on, 5 minutes. No pause again. No pause, record. Let me see what you all do. Come on. All right, guys, ready? My time. Let's go. Let's talk about it first. So, the question is asking us for the equation of BC. It's this line right here. Remember, to find the equation of any line, just remember, you need to know 2 things about it. You need a gradient and a point. You have a point already. What you don't have is a gradient. But you also know that it is perpendicular to this line beside, adjacent to it. Right? Because you have the coordinates of this line AB, you can find the gradient of AB. Gradient of AB. You can find the gradient of AB. They do the negative reciprocal of that, that gives you this gradient. And then with that perpendicular gradient at this point, then you will get the equation. You will then have the equation of BC, as simple as that. So it's a matter of remembering that you need a gradient and a point. You have a point already, look to see how you're going to find the gradient. Right? Either gonna use that it is parallel to a line or it is perpendicular to a line. All right, so let's go. Let's do it over here. Let's do it over here. I'm leaving the diagram on the screen there. I know what I want. I know that I want the line BC. I know that I want the coordinates of C, and I know that I want the coordinates of D, right? Ready. So I'm trying to find BC first. I need a gradient and a point. I'm trying to find BC first. I know the point I'm going to use already is B negative 2, 8. I know the point already. I want the gradient of BC. Gradient of BC is minus 1 over the gradient of AB, because this is perpendicular to AB. Where the gradient of AB, because I have the coordinates, is equal to the difference in y over the difference in x between these 2 points. These 2 points. Going from left to right, this is my destination point, this is my starting point. I'm going to do this y value minus this y value. So it's 14 minus 8 over this x value minus this x value. That is 2 minus a negative 2. 40 minus 8 is how much? 6. Plus here, so give me what? 4. So the gradient of AB simplifies to 3 over 2. So the purple gradient right here, I don't calculate it, just flip this and change the sign. So it means that the gradient of BC, becomes negative 2/3. So I'm using this gradient and this point now to find the equation of BC. So the equation becomes y minus yb, b is the point, equals the gradient of BC, we know it now, into x minus xb. I told you that this is the equation that we'll mostly use. This form for the equation of a line that we'll mostly use. But most times you'll have a gradient and a point. That is not the y-axis intersect. So it becomes y minus yb is 8. So it's y minus 8. The gradient of BC is minus 2/3. Minus 2/3. Into x minus xa is negative 2. So it becomes a negative 2 right here. This minus minus a plus. I'm going to put a plus in red. So don't forget it. That's a plus. To simplify this now, I'm going to multiply this denominator across here by these 2 values. And I'm going to multiply this negative 2 inside here by these 2 values. To simplify. All right? So watch it now. So this denominator, I'm multiplying it across here, because I don't want the fractions all over the place. So it's going to become 3y minus 24. What is that? Equal, I'm multiplying the negative 2 inside the bracket now. I get negative 2 times x is negative 2x. But this is negative 2 times a positive 2. Becomes a negative 4. Transpose this 24 over here and add it. I get 3y equals negative 2x plus 20. That becomes a positive 24 minus 4. Get plus 20. That is the equation of this, right? This. That's my answer for this. The next thing I want me to find is the coordinates of C. Easy. C is on BC and the y value is 0. Don't it? So we can say 2 things about the point C for part 2. At the point C, we have the equation of BC is valid. 3y is equal to minus 2x plus 20. And also, y is equal to 0. So that we solve the simultaneous equation again now. C is the intersection of the x-axis, which is y equals 0, and this line. Solve them simultaneously. Or I just plug the minus, plug the 0 here. In any case, what it becomes that this thing becomes equal to 0, don't it? If I put the 0 here for the y. Agreed? So I can say, therefore, 0 equals minus 2x plus 20. So therefore, x equals 10. So therefore, C is a point 10, 0. C is a point 10, 0. Then they ask for the coordinates of D now, which is the easiest part of the question. D is the easiest part of the question. D, part 3. To find the coordinates of D. Somebody tell me I just need to write it out. How do I find the coordinates of D? We're at this point now is, what is it? 10, 0. How do I find the coordinates of D up here, so? Nobody? Huh? Put the points in the gradient. Equation of what? Huh? You don't want to do it on hard way, man. This gradient and this gradient are the same. That's what you're saying, all right? Good, and then on.
So with the rise and the inserts together, the rise and run from C.
You know, the rise and run from here to here. And then on.
You can choose the point C, sir,
Uh-huh.
and figure point C.
Exactly. This line and this line are the same in every way. Them parallel and them have the same length. They have the same length, you know, and then parallel. So it means that the change in x, same change from here to here, so. It's the same change from here to here, so. If you want to do the x first, the x come this way and then go up to there. It's the same change when I go from here to here, so. Same change. What did we do here? We add 4, don't it? So here says a plus 4. So plus 4. A bit stuck. Right. So here's our plus 4. And from 8 to 14 plus 6. Don't it? So all we have to do is just plus 4 again down here, so. And plus 6. So the coordinates of D becomes 10 plus 4, 0 plus 6. So D is a point 14, 6. No calculation needed. But as on that, same length, same gradient. So the change in x is the same, the change in y is the same. The change in x is a plus 4, the change in y is a plus 6. So just change my x the same amount, change my y the same amount. But the online, but I go to that.
So can you say it one more time, please?
Yes, sir.
Say it one more time. Let's say it one more time. Let me zoom it up and say it one more time. All right. Let me zoom it up. So what I'm saying is that because it's a rectangle, these two lines are equal in every way, meaning they are parallel and they have the same length. Then parallel and they also have the same length. So it means that from this point to this point, the changes in the coordinates must be exactly the same. From this point to this point, must be the same change. So how did the x value change from this point? It went from -2 to 2. In other words, we increase across here by 4. A change of 4. The x value increased by 4. And then we went up. The y value go from 8 to 14. It increased by 6. So from here to here, the same change must happen. Where we know the coordinates of this point is 10, 0. Starting at 10, 0. To go to this point, the change in x must be the same as this. 4 across. So this is a plus 4. And the change in the y value must be the same. Plus 6. Plus 6. So this coordinate D has to be 10 plus 4, which is 14, and 0 plus 6, which is 6. Because the two lines are the same length and the same gradient. So the changes in the coordinates must be the same on the two lines. They are the same length and they are the same slope. So the changes in the coordinates from point to point must be the same change. So there's no need for any calculation in these questions. No need for calculation. Understand that now?
Yes, sir.
All right, good. So these are some things that maybe in CSEC wouldn't have considered, but you know, we must at this level now, you have to understand and apply these things. All right. Let me put up another question on the screen. More maths equals better maths. So let me put up another one for you. Let me see which one I'm going to give you next. Let me see which one I'm going to give you. I'm not going to give anything too hard. Let me see which one I'm going to give you next. All right. You don't want to see that. What a lot of questions on this page. All right. Let me give you this one. I'll give you the diagram once. Let's do the diagram once. We can do the calculation once. The worded ones another time. Come, I'm giving you 5 minutes to do this one. 5 minutes to do this one in a box. Five minutes to do that one right there. It says in the diagram, A and C lie on the X and Y axis respectively, X and Y axis respectively. And the equation of AC is 2y plus x equals 16. That gives us the equation of this line. The equation of this line is this equation right here, the Taylor equation. And then they also say that this is on the y-axis, that's on the x-axis. So what they have said in the diagram is here. This equation is for this line is. It says B has coordinates 2, 2. See there? B has coordinates 2, 2. That's on the diagram. And the perpendicular from B to C. See there? This is the perpendicular from B to AC. This is the perpendicular from B to AC. See the perpendicular. Meets AC at point X. See there? So this is line. We're discussing this line. This line is perpendicular to AC, and it meets AC at point X. You can see it on the diagram. Right here says perpendicular. So this line is perpendicular to this line. Those two lines are perpendicular. So you know, so negative reciprocal gradient will come into play right here. Find the coordinates of X. Find the coordinates of X. Let me tell you, X clearly is the intersection of these two lines. Easy as that. That's what X is, you know, the intersection of those two lines. Find the two equations and solve them simultaneously. Actually give you one already. All right? I'm telling you what to do. Giving you some help. Then, next part now says the point D is such that the quadrilateral ABCD is AC as a line of symmetry. So they're telling you now, let me tell you what they say. Let me put it on the diagram. I'm helping you. It says the point D is such that quadrilateral ABCD, A to B to C, D somewhere over here, is such that this line is a line of symmetry now. This line. The line of symmetry. It simply means that this length across here so is the same as this length. That's what it means. That's what I said. How you say D? This point is D. Right? Find the coordinates of D. Easy. Find the coordinates of D. Right? Remember, I don't know B, I don't know X. Right there. Then now find correct one decimal place, the perimeter of A. I don't know about that last part. Let's find the coordinates of B. Don't worry about the perimeter yet. The last part. Find the perimeter. Find the perimeter. So basically, to find the perimeter, I need this length and this length. Find those two lengths. Right? And then you multiply by 2, so you get this and this. Multiply by 2. That's how you could find the perimeter. Right? Find those two lengths and multiply by 2 to get the last part. I don't pause the video now. 5 minutes. Time is 30. Starting back at 40. And pause the video. All right, guys, my time. Time's up. So, remember now, they gave us the equation of this line, right? So from that equation, we can find the gradient of this line. But the perpendicular to this. So we can use that gradient and find the gradient of this line. Then the gradient of this line and this point gives us the equation of Bx. Then we solve Bx. We solve simultaneously Bx and this line to get the point x. That's all. That is all. So in this equation here that they gave us, I'm going to put it up here. So if we make y the subject, we're going to get y equals minus half x plus 8. What is that? Y equals minus half x plus 8. So it means that this y-axis intercept up here says 8. That's all. So that point is simply the point 0, 8. Up here says the point 0, 8. See the point 0, 8. And then down here, so now, is where y equals 0. If y equals 0 back in the original equation here, so then x equals 16. See that? See that? So x equals 16. So down here, so is the point then. 16, 0. Yes, so the question is easy. See that? Then the gradient of this line is a half. That minus half of me. So it simply means that the gradient of this line is 2. Negative reciprocal of that. See that? Gradient of that line is 2. And the gradient of that line is 2. And it passes through 2, 2. Then that line becomes y minus 2. That is the y value. Equals the gradient of 2 into x minus 2. Everything on this line is just 2, 2, 2. But the partial point 2, 2, and have a gradient of 2. What else why it have a gradient of 2? Okay, perpendicular to this one where the gradient is minus half. Negative reciprocal of half is 2. So that gives us a gradient down here. So this becomes y equals 2x. This one is given minus 4. Minus 4 plus 2 is negative 2. So I get a negative 2 right here. That's the equation of that line. Yes. People online got that? Anybody in there got that?
Yes, sir.
All right. That's the equation of bx. Then we want the coordinates of x. What we do? Solve bx and this line simultaneously. So I'm going to solve that simultaneously now with the 2y plus x equals 16. This is going to give me the point x. 2 lines meet at x. So I'm solving those two equations simultaneously. This one has y as a subject. I'm going to take this. I'm going to take this and drop it inside here for the y. Substitute. All right? So this is going to produce for me that 2 into 2x minus 2 plus x equals 16. So this is 4x. So this is negative 4 plus x equals 16. So this one is a 5x. This go over here and become 20. 5x equals 20, so x equals 4. Then when x equals 4, now I'm going to take the 4 and drop it right in here, so to find the y value. 4 is 8. 8 minus 2 is 6. So the y value is 6. So therefore, x is the point 4, 6. X is the point 4, 6. Then they tell us about this quadrilateral. Huh? can get from the equation. These are the equation of that line. These are the y-axis intercept 8. Note it. The point is 0, 8. So, then now, down here, so on the x-axis, y equals 0, so put 0 here, so you get x equals 16. So, that point. Easy as that. Eh? Similarly, up here, if I put on the y-axis, x equals 0, I put 0 here for the x. Now I get 2y equals 16. 2y equals 16 and y equals 8. But we have the equation in the standard form we use it. Y equals mx plus c. We have the equation of the line in this form. Therefore, this is the y-axis intercept 0, 8. And then I use this one conveniently down here. Because I know so the y value equals 0 there, so x equals 16 down this. Good? Alright. So let's tell us about this point across, you know, that when does this thing symmetrical about ax? I'm gonna say this go like so, and go like so. And if this line is symmetrical, if I extend this line across here, bx, then over here says d. And I have to calculate d line. What have to calculate d? What have to calculate d? That's a similar thing. This piece and this piece is the same in every way. Same length and same gradient. That's all. So the change in x from here to here is the same change from here to there. What was x again? Point x. Point x came out to be 4, 6. So the point x came out to be 4, 6. So right here says 4, 6. Right here so is the point 4, 6. You can write down the coordinates of d easily. 2 add 2 to each other, add 2 more to each other, so this is 6. Understand that? From here to here, so I add 4, if you have 4 more for each other, so this is 10. So d is a point 610. In the calculation. But so that d is a point 610. That's it. This line and this line is the same length and same gradient. So the change in x from here to here is the same change from here to here. Increase by 2. And y increased by 4 come here. So must increase by 4 again to go better. So has the same length and same slope. No calculation needed. See that? According of d. And the last part now is asking us for the perimeter. The perimeter of the whole thing. Now what's now? The length here and the length here are the same. Don't it? And the length here and the length here is the same. So to find the perimeter, all I have to do is calculate, put it in Greek. To find the perimeter, I just calculate this length and calculate this length. Calculate them 2 length there and multiply by 2. And the perimeter. See that? The length is easy to find because the coordinate include 0. So basically from here so to here so horizontally is 14 and up here so is 2 to get this length. Right? I'm not sure what I mean by that. On the length of this line up here, so this line. I know that this length here so is 14. Again, and up here so is 2. So we write on the triangle 42. So the length of BA, there BA become the square root of 2 squared and 14 squared. That's BA now. And then we can do a similar thing with this side. Right? Because from here so to here so, that change of 2, and then from here so to here so, that change of 6. Right? Look again. From 2 to 0, the change of 2. And from 2 to 8, the change of 6. That's change in x and the change in y. So this BC is the square root of 2 squared plus 6 squared. This is changing x and that is changing y. Those give you the two letters and multiply that by 2. Done. You understand that, guys? Online, you understand it? Yes?
Yes, sir.
Yes,
Huh?
sir.
Come get the what? You stand up here, sir? Because from 2 to 6 is an increase of 4. So to come over here, so it's about increase 4 more again, increase 10. Because the length here, so, and the length here, so, is the same. See that? So the change in the coordinates, changing the coordinates, the different color, black. Changing the coordinates from this point up to this middle point. The same change up to here. Because the length of the line segments are the same and they have the same slope. So the change in the values must be the same. The x value is increased by the same amount, and the y value is increased by the same amount. Because it's the same length line and the same slope line. Get me? I do the mathematics the easy way every time. No calculation you need for that. Why what? Why increase by 4? Because from 2 to 6, what is the difference? 4. Let me now increase 6 by 4 again. Huh? You see it? From 2 to 6, that's an increase of 4. So the next jump is by 4 more, because the same length I jump by. See now? Understand? Good. Simple. It's not complicated. Really. Anybody else have any question? All right. More maths equals better maths. One more for the road. So you know, say me say come back Friday, come do some more of these, right? You're gonna look so comfortable. You're gonna fly through them. Huh? You will go back to your notes. Well, I will know. I don't know why whatever means. No matter what you want to do. Just look, get comfortable doing them for me. Whatever you want to do. Come, one more. 40 days out. One more. More maths equals better maths. Every time. All right, I'll give you a worded one. I'll give you a worded one. No diagram. Let's give you a worded one to finish up. The line and the curve and 2 points. Let's see. Hola. Huh? Awesome. Yeah, no, do all the thing them. All right, easy question. Most can do this. Most can do like a worded question to finish out the class. Most. That look at number 2 question here. Can't tell me something can't done 5 minutes. Say no 6:51. 6:56. No 6:56. Right? I'm giving until 7:01 to do it. 7:01. Start. Start. The easy question. Easy. Easy. Go on, start it. Pause. All right, guys, let's do this. All right. So I'm gonna let me split the screen and just maybe learn to sketch and show you. All right. Learn to sketch. Sometimes during these questions, you know, you want to visualize it. Right? So let's go to sketch of what they've said. The totals of a line 1. If you put this in the form y equals mx plus b, it's going to be y equals minus 2x plus 8. Those are a negative gradient. So it's basically a slope like this. That will be line 1. And line 2 is perpendicular to it. And they give us the equation of line 1, right? Which is y equals minus 2x plus 8. If I put it in standard form. Then the totals of a line 2, which is perpendicular to line 1. This is line 2 now. But line 2 passes to a point A, which is 7, 4. And they tell us that line 1 and line 2 meet at B. So it means that right here says B, where they intersect each other. That's the diagram. Find the equation of line 2. So one find the equation of this line 2. We need a gradient and a point. Well, the point already, so all we really need is a gradient. No, the gradient of line 2 is minus 1 over the gradient of line 1. Because they're perpendicular. Gradient of line 1 is negative 2, so gradient of line 2 is a half. If you flip negative 2 and change the sign, get a half. We're going to use a half and this point now to find the equation of line 2. Gradient is a half, and the point to pass through is 7, 4. Right? So the line 2 equation is y minus ya equals the gradient of line 2 into x minus xa. Because y minus ya is 4. The gradient of line 2 is a half right there. X minus xa is 7. I'm going to take the 2 and multiply it over here. And then I'm going to multiply the 1 inside here. So I'm going to get the 2 times these across there, give me 2y minus 8 equals x minus 7. Take this over here and become a plus. I get 2y equals x plus 1. That's the equation of that line, x plus 1. 2y equals x plus 1. This is the equation of line 2. The question says must find the length of AB. To find the length of AB, I need to find the coordinates of B and then use the length of line formula. I need to find the coordinates of B. B is the point of intersection of the 2 lines. So I solve the 2 of them simultaneously. So I can say something like at B. At B, the equation of the 2 lines valid. Line 1 valid, which is 2x plus y equals 8. And line 2 valid as well, which is, in fact, what I'll do, I write line 1 in the standard form, this one. So line 1, which is y equals minus 2x plus 8. And the line 2 is 2y equals x plus 1. This is line 1 and this is line 2. The 2 of them happening at point B. So you can solve them simultaneously. So I can take this, that the first line says y equals 2 and drop it inside here for the y. In the second line. When I do that, I get 2y, so I'm going to sub 1 into 2. I'm going to get 2 times minus 2x plus 8 equals x plus 1. This is minus 4x plus 16 equals x plus 1. That means 5x over here equals, bring over this and subtract, we get 15 over here. So the x equals 3, we divide 2 by 5. And if the x equals 3, we take the 3 and drop it in this equation for the x. And so we can say, and the y becomes minus 2 times 3 plus 8. That becomes 2, because this is negative 6. So it means then that B is a point 3, 2. 3, 2. Remember, A is a point 7, 4. You need a length AB now. Equals the square root. Difference in the x value squared. This x value minus this x value. 7 minus 3 squared. Plus difference in the y value squared. This y value minus this y value. That gives it square root. This is 4 square, which is 16. This is 2 square, which is 4. The answer becomes the square root of 20 units. So, all right, guys. On the good?
Yes, sir, I got that.
Wow, beautiful, beautiful. We start class later now. Anyway, guys, watch me now. You can screenshot these for me, please, and do these questions. Screenshot and do these questions for homework, please. I'm not finished yet. I have some others for you. Screenshot and do those questions for homework, please. In the book. In the booklet. In the booklet. The people online in particular, screenshot. First, those screenshot, you can send it in the WhatsApp group, please. The class WhatsApp group. Let me bring up the next one. Not finished yet. You're also supposed to do some of these questions. Like, for example, this one up here. These, we didn't do these. These up here. That's 3 questions up here, so we didn't do. 3 questions up there. Screenshot again and send that in the group, please. There's also one up here. A very nice question to do as well. This one. Yeah. Oh, this is not the thing there. Now the homework. That was screenshot the homework. Oh, see it here. It's in here, yeah? See it here. Yeah, that one. Huh? It's in handout, you know. For the workout, I'm gonna send the video. You know. You want the workout? Which part do you want to see now? You want to see right here? You need a diagram. Can take that for the screen. Can take that for the screen. All right, guys. Next class is Friday. I decided if I'm moving on to circles, I will do some more of these on Friday. I decide. I feel like I need to do some more of these on Friday. Huh? You know what it is? You know what the display? No, this is not Admas either. The circles in Admas as well. You better not get a question Admas with this. You more get the circles question and you have to find tangent and normal and so on.
Yeah, I think we've got this in our choice.
Yeah, you get something like this in multiple choice. Yeah. All right, guys, online. See you all on Friday. I'm gonna send this video to the group later as soon as I get it. You can watch over the video if necessary, and you know. So I put the homework on the screen. You need to just do those questions, some of these for Friday. Everybody Okay? Okay, guys, online, I'm speaking to you.
Okay, sir. All
All
right.
right. Try the questions one, please. And when I send it, I need to redo the examples that we did today as well. All right, bye, Kai. Bye, Shade.
Bye
Bye,
bye.
sir.
All right, bye-bye. Huh? When? That's what I was saying. I'm thinking about starting it on Saturday.